An extension of example 3. We are expected to sketch the graph of y is equals to cosec theta. And basically we know when we are talking about y is equals to cosec theta, we are simply talking about y is equals to 1 over sine theta. So we need to have, first of all, the graph of y is equals to sine theta, after which we reciprocate to get the value of y when we have 1 over sine theta, which is actually cosec theta. And from the range of negative 360 to positive 360, we need to identify the value of theta when sine theta was 0. And of course, we start with sine negative 360 is supposed to be 0. And because we know 1 over 0 is undefined, then we know we are going to have an asymptote along that line. Again, we know that sine of negative 180 was 0, or is still 0. 1 over 0 is not defined. Again, we know we are going to have an asymptote along that negative 180 degrees. Sine 0 is 0, another asymptote. Sine 180 is 0, another asymptote. And sine 360, which is 0, and we have another asymptote at that particular point. But it is what happens immediately after the asymptotes and before asymptotes, which gives us the nature of our graph. For example, there is an asymptote on negative 360 degrees, meaning that if you want to know the sine of negative 359 degrees, which is slightly on the right of the asymptote, the sine of negative 359 degrees is a very small positive number, specifically 0.017. When you now have 1 over 0.017, 1 divided by a small positive number gives you a very big positive number. So it is headed to the positive. But when we're talking about the sine of negative 270 degrees is actually 1. And 1 over 1 remains 1. But what happens just before we get to the next asymptote? We know that this is negative 181 from this line to the left, slightly to the left. So what is the sine of negative 181 degrees? This is another very small positive number, and 1 divided by 0.0174 is another very big positive number. So we are talking of a graph that really looks like that. But it is interesting to note that immediately after negative 180 to the right, let's talk about the sine of negative 179, which is a very small negative number, specifically negative 0.0174, and 1 over that very small negative number is a very big negative number. Again, the sine of 90 is negative 1. 1 over negative 1 doesn't change. And of course, we expect the curve to have this kind of a shape. But before we identify, we conclusively say this is the shape. Let's identify what happens just before we get to 0. For example, the sine of negative 1 degree, which is another very small negative number, and 1 over a small negative number becomes a big negative number. So you realize that this is now the shape of that particular graph. When we go to the right, again, sine 1 degree is a very small positive number, so you expect this kind of a curve. And of course, alternatively, you can see we are having this curve that way, alternating to the lower side, the upper side, the lower side, and the upper side. So we have that kind of a graph that explains the curve of y is equals to cosec theta. Now, something to note. You can see the domain of y is equals to cosec theta is a real number. And of course, x is not supposed to be 0 because we do not have a specific value of y when x is equals to 0. The domain is any real number, but not the domain is any real number, which is of course the domain is explained by x, but x is not supposed to be 0. Of course, it is also important for anybody to note that as much as the domain is not equals to 0, it's also not supposed to be equals to 180 degrees, because you can see when x is 180 degrees, then we do not have a specific value of y, and x is also not supposed to be 360, x is not supposed to be negative 180, and x is not supposed to be negative 360, as you can see. But what about the range? The range of y is equals to cosec x is, you will find that the range, this is now the range, and the range we are always talking about the value of y. In domain, we are always talking about the value of x. The range, you'll see, it can have all the values of y starting from -1 going downwards, so y is less than or equals to -1. And at some point, you can also see y can assume the value of 1, or moving forward, y is also equals to greater than or equals to 1. Those are the range of the graph of y is equals to cosec x. All right.